Now, I shall introduce here you phenomena of maxima and minima. This chapter is very important from the point of view of examination. In every competitive examination, at least there are 2 to 3 questions. I shall try my best to simplify this chapter in such a manner that in competitive examination, you may do the question within 1 minute. Though every question cannot be done orally, but I shall try to simplify it in such a manner that you can do the question within 1 minute. What it says, concept of the maxima is this: if a function fx is maximum at x equal to a, then its value at x equal to a shall be highest. Its value at x equal to a shall be highest in neighborhood of a. In neighborhood of a. What is the meaning of neighborhood? So, H neighborhood of a is all the quantities in between open interval a minus h and a plus h. All the quantities in the open interval a minus h, a plus h, it means a minus h is less than x. A is less than a plus h. Then we say that x belongs to open interval a minus h, a plus h. Similarly, what is the meaning of the minima? If value of the function at x equal to a, if value of the function at x equal to a is lowest in its neighborhood, then what we say function is minimum at x equal to a. Minimum at x equal to a. Now we can test the maxima minima by 2 ways. First method is first order derivative method, and second method is second order derivative method. Most of the time in competitive examination, the first order derivative method is suitable. First order derivative method is suitable. So let us study how we can find this. Everything I shall explain you by a graph. By a graph. Let us see, this is a function. Let this point is x equal to a. Then what we see, at x equal to a, function is increasing here, and at x equal to a, it is stationary. So if I draw the tangent at x equal to a, then it will be parallel to x-axis. That is, dy upon dx will be 0 at x equal to a. And what is the other thing? In left of a means fa minus a, in left of a, function is increasing, and in right of a, function is decreasing. So what we can see, f dash a minus h is greater than 0, f dash a is equal to 0, and f dash a plus h is less than 0. Then what we see, function is maximum at x equal to a. A is called stationary point if we draw tangent at x equal to a, tangent at x equal to a, then it shall be parallel to x-axis. So what you do? Find dy upon dx. If it changes its sign from positive to negative, because f dash a minus h is greater than 0, if it changes its sign from positive to negative, then function is maximum at x equal to a. So this is point of maxima, this is also point of maxima, point A is point of maxima, point B is point of maxima, because in both the cases function is first increasing, then stationary and then decreasing. F dash A minus H is greater than 0, F dash A plus H means decreasing, less than 0, and F dash A equal to 0. Same thing is here at point B also, first increasing, then decreasing. Again see, this is point C, here what we see, function is first decreasing, at C it is, function is first decreasing, at C it is stationary, so tangent at C shall be parallel to x-axis, and then function is increasing, so C is point of minima. So for minima, what you can see, what is this? F dash A minus H, F dash A minus H, F dash A minus H is less than 0, F dash A equal to 0, F dash A plus H greater than 0, function is minimum at x equal to A is minimum. If f dash A equal to 0, but it does not change its sign from left to right, then function is called neither maximum nor minimum at x equal to A, and such points are called point of inflection. So this is the first method. Now one important point is here. We have told f dash A equal to 0. So what happens if function is not differentiable at x equal to A? Maxima and minima can exist if function is not differentiable at x equal to A, but if it changes sign from positive to negative, it will be maxima, negative to positive, it will be minima. For example, if I see fx equal to mod of x, if I write it properly, it shall be fx equal to minus x when x is less than 0, x when x is greater than 0. This function is not differentiable at x equal to 0, because in left differentiation is minus 1, right differentiation is 1. First, this function is not differentiable at x equal to 0, left differentiation is minus 1, right is 1. So it changes its sign from negative to positive, so it shall be minimum. This question has been asked in competitive exam, minimum at x equal to 0. मैं फिर से रिपीट कर रहा हूँ, I am repeating it again. Function is not differentiable at x equal to 0, but it changes its sign from negative to positive, so function will be minimum at x equal to 0. Function shall be minimum at x equal to 0. For example, now see fx equal to x square. Fx equal to x square. Then correct statement is this. So let us see f dash x 2x, f dash 0 minus h, this will be minus 2h, f dash 0 plus h, that still be 2h. F dash 0 equal to 0. Left differentiation is negative, right differentiation is positive. So function is minimum. This is less than 0. Left में in left it is less than 0 and in right of 0 it is greater than 0. So function is minimum at x equal to 0. Next is fx equal to x cube. Differentiate it. F dash x 3x square. F dash 0 is 0. F dash 0 minus h 3h square. F dash 0 plus h 3h square. Though f dash 0 is 0, but it does not change its sign. So function is neither maximum nor minimum. So this is point of inflection. This is good question. So let us see again next question. Fx equal to mod of x. This question I have done. Maximum, minimum at x equal to 0. So again I am telling you fx equal to mod of x. This can be written as fx equal to minus x. X is less than 0, x when x is greater than 0. So function is minimum at x equal to 0. Now before doing maxima minima, let us see certain important points which can simplify your problem. So first thing is this. Wherever fx is maximum or minimum, first point, wherever fx is maximum or minimum, fx whole square shall also be maximum or minimum. Second, where fx is maximum or minimum, log of fx shall also be maximum or minimum. Log of fx shall also be maximum or minimum. Next is, ये कहता है, what it says, where fx is maximum, 1 upon fx shall be minimum, and where fx is minimum, 1 upon fx shall be maximum. You have to keep three things in your mind for just simplification of the question. First is this, wherever fx is maximum or minimum, fx whole square shall also be maximum and minimum. So for example, if you want to check the maximum minima of under root of x square plus 1, if you want to check that maxima or minima of under root of x square plus 1, in spite of finding maxima minima of under root of x square plus 1, you find the maxima minima of square of this x square plus 1. Similarly, if you want to find the maxima minima of x raised to x, you can find the maxima minima of log of this x log of x. You take the logarithm and then find the maxima. And third is, if you want to find the maxima minima of 1 upon sin x plus cos x, you find the maxima minima of sin x plus cos x. You find the maxima minima of sin x plus cos x, and then you reverse the result. You reverse the result. So I am doing this question. It is pi by 4, not root 4. It is pi by 4. This is pi by 4. Pi by 4. This is pi by 4. So let us do this question. 1 upon sin x plus cos x है. ये कहता है कि what is the correct statement? Maxima at pi by 4, minima at pi by 4, increasing in pi by 4, neither maxima nor minima at x equal to pi by 4. What I told you, in spite of finding the maxima minima of fx, you can find the maxima minima of 1 upon fx and then reverse the result. So let us see how we can do this question. Fx is equal to one upon sin x plus cos x. Though we can do it directly, but if I find the maxima minima of sin x plus cos x, differentiate it, cos x minus sin x. Now see, let us see at x equal to pi by 4. At x equal to pi by 4, g dash pi by 4 equal to 0. In left of pi by 4, in left of pi by 4, it will be positive. So g dash pi by 4 minus h is greater than 0. G dash pi by 4 plus h is less than 0, and g dash pi by 4 equal to 0. So what we see, gx is maximum, gx is maximum gx is maximum at x equal to pi by 4. Now what I told you, you find the maxima minima of 1 upon fx and then reverse the result. Gx is maximum at pi by 4. So fx is minimum at pi by 4. Fx is minimum at pi by 4. So correct statement is, this function is minimum at x equal to pi by 4. Now second is fx equal to 1 upon x square plus x plus 1. Correct statement is maxima at x equal to 1, minima at x equal to 1. Maxima, neither maxima nor minima at x equal to 0, none. So if I take f dash x, this will be minus 2x plus 1 upon x square plus x plus 1 whole square. So f dash half will be 0. At x equal to 1, f dash 1 is not equal to 0. First answer cannot be there. Maxima at x equal to 1, minima at x equal to 1, neither maxima nor minima at x equal to 0. So this is answer is none. Because to be maxima or minima, f dash a should be equal to 0, and at x equal to 1 or 0, f dash is not equal to 0. Next is fx equal to, this is very good question, fx equal to x minus 2 ka whole cube, x minus 3 ka whole raised to 4. In certain questions what you do, first find out f dash x. This will be 3 x minus 2 ka whole square, x minus 3 whole raised to 4 plus 4 x minus 2 ka whole cube, x minus 3 ka whole cube. I can take common x minus 2 ka whole square, x minus 3 ka whole cube, so this will be 3x minus 9 plus 4x minus 8. Now, how many points will be there? How many points will be there where it can be 0? X equal to 2, 3 and 7x minus 17 means x equal to 17 by 7. Now let us see about x minus 2. It is x minus 2 whole square. So naturally, it will not change sign in left of 2 and right of 2 because this is whole square. So function will be neither maximum nor minimum at x equal to 2. Neither maximum nor minimum at x equal to 2, and now let us see x equal to 2, neither maxima nor minima, x equal to 3 and 2, neither maxima nor minima not appear, neither maxima nor minima. So once you differentiate it, let us see how it changes the sign. Let us see again, though he has not asked the question. This is 17 by 7, so 17 by 7 is less than 3. So let us see, in left of 3, it will be negative. यहाँ पे it will be here also negative, positive, positive to negative. So it will be maxima at x equal to 3. Now let us see again next question. Same type of the question is there. Fx equal to x square e की power minus x. Then correct statement is differentiate it 2x e की power minus x plus minus x square e की power minus x. Let us see what can we do. If I take x e raised to minus x common, it will be 2 minus x. Now let's see where it will be 0, either at x equal to 0 or at x equal to 2. So stationary points will be 0 and 2. 0 and 2. Now see, he has given the answer only at 2, so we shall check it only for 2. If I put in left of 2, less than 2, it will be positive. It will be positive. For greater than 2, it shall be negative. So it changes its sign from positive to negative. I am again explaining, I have differentiated it, and differentiation is this 2x e की power minus x square e की power minus x. If I take x e की power minus x common, what shall happen? It will be 2 minus x. Now, in 4 answers, though there are 2 stationary points, 0 and 2, but he has only asked the answer in the form of 2. So, what we'll do? We do take the left of 2, left of the 2 means less than 2, it will be positive. If I take greater than 2, it shall be negative. So it is positive to negative. So maxima at x equal to 2. This is good question. Maxima at x equal to 2. First order derivative method is very important. Fx equal to x raised to x. Take x log of x. Differentiate it. So 1 plus log x. X raised to x, 1 plus log x. So then correct statement is at x equal to 1 upon e. So if I put log x plus 1 equal to 0, log x equal to minus 1, x equal to e की power minus 1. Now, if you wish, you can do it by second order derivative method also. So, if I differentiate it, y, differentiate it again, d2y by dx square will be equal to 1 upon e, 1 upon x. At x equal to 1 upon e, d2y by dx square, d2y by dx square shall be greater than 0, So minima at 1 upon e. You can do it by putting 1 upon e, left of 1 upon e, and then right of 1 upon e. You will see it that function changes its sign from negative to positive, negative to positive. So this will be minima at 1 upon e. Once this has been asked, second order derivative, I have written d2y by dx square, that we shall study in next part by second order derivative method. Same is here, 14. Take log of both sides, y equal to sine raised to p theta, cos raised to q theta. All those questions can be taken by this. Higher order derivative method. Now, in this part, in first part we are seeing how we can test the maxima minima by first order derivative method. Now we shall study second order derivative method. So in next video we shall